Okay, start recording. I think that this is going to work. We're going to find out. I'm in a new studio, and so we're going to look at the extra examples for 2.1. Let me see if I can find my paper view, and we have a new setup. So I'm working with that and learning how to do that. It's this, so I have no choice but the furthest one. Okay, and it seems like it's focused okay. So it says find the equation of the tangent line to the curve at the given point. So anytime that someone asks me to find the equation of the tangent line, get some ink on my pencil, get some tea in my jug. Those are the things you got to know. But I'm going to need to know the slope of the tangent line. And I'm also going to need to know the point that they want it at. Now, good news, they've given me the point, -1, 2. So perfect. They've been given the point. At this point, we only are to use the definition of the derivative. It didn't say up here use the definition of the derivative, but that's the section we're in. The only time that you use the definition of the derivative and not the shortcut rule is if that's what the directions say to do. So I'm going to say that we have to use the definition of the derivative. So I'm going to write down the definition of the derivative right here, or the definition of the slope of the tangent line. So let's see here. That is, so you could call it, if you liked, m tan, slope of the tangent line, and it's the limit. And there's two of them that I get to choose from. So one that has an f at x plus h, and one that has f at x minus f at a divided by. So I get to choose which one. On this one, it's a toss-up which one to do. And so I think I'll use the one that's like this. X goes to a, like this, of f at x minus f at a divided by x minus a. So on this particular example that we have, our a value is -1 right here. Our a value is -1, and actually our f at a value right here is f at a value is 2. And so if you wanted to verify that that was true, let's say that I wrote my function like this: f at x equals the square root of 1 minus 3x, right? But instead of x, I'm going to put parentheses right here, and I'm going to fill in the blank here, and what I'm going to be plugging in is -1. And I'm going to show you, if I put in -1 there, that I for sure get 2. And so that would be the square root of 1 plus 3, which is the square root of 4, which is certainly equal to 2. And so so that's the good news on that, is that they gave me that point. I didn't need to find it. If I needed to find it, I could have found it. So as I use this formula right here to find the slope, we have the limit as x goes to a, which is in this case -1. And then we have f at x, which is just coming to this function where I had the blank in it. I'll put it with the blank again, and plugging in 1 minus 3x, plugging in x right here. And so you're saying, that's just that. And you're right, that is just that. So this is the square root of 1 minus 3x, and then minus f at a, which we found was 2, divided by x minus -1. And I'll fix that up, that's x plus 1, right? And so now as I look at this, if I was to plug in -1 right in here, -1, then this would be equal to 2, and 2 minus 2 is 0. The numerator would be 0. And if I put in -1 in the denominator, well, this is x of minus 1 is plus 1. If I put in -1 here, it'd be -1 plus 1, which would be 0. So it would be 0 over 0. So that's the reason I'm not plugging in right now. I want to fix my -1 right here and not have to take a whole step to do that. Will you guys allow that? A negative is a positive. Are you guys cool with that? So I'm going to put plus 1 right there. Okay. So whenever you have 0 over 0 and you're finding a limit, that's what I have right now, right? I have 0 over 0, which is indeterminate. And what that means, I'm not going to be able to spell indeterminate in that little tiny spot, but I barely fit it on there. I guess I have more room than it looks like I have here in person. Right there. Whenever you have a square root, that means multiply by the conjugate. So that's what I'm saying to myself. Oh, I got to multiply by the conjugate. Now, how you get the conjugate is you just, we're going to come right here. I'm going to put parentheses around this right here, times, and you just turn that right there, that minus, into a plus. If it was a minus, you do a plus, and if it was a plus, you do a minus. So you just do the opposite right here. So this is 2. What you do in the numerator, you got to do in the denominator. I'm going to write parentheses around the x plus 1 there because it's binomial. And then plus 2. And that 2 is, that plus sign is not underneath my square root. I haven't got my setup completely good yet. I'm kind of almost sitting in a hole. And so I'm lower than my paper, and I'm about to get a pillow. That's what I could do, is I could sit on a pillow, and that would make me a tiny bit taller for this desk I got at this setup. Yeah, that's a little bit better. Okay, so what I need to do is I need to FOIL here, and when I FOIL here, the outer and the inner are going to make 0. And so I'm going to go ahead and just multiply the first and the last. I haven't found the limit yet, so I'm going to write the limit sign to show that eventually I will get to a place that I can plug in and find the limit, and it won't be 0 over 0, but it's not happening right this moment. So, and so I'm going to multiply by the first, which is going to give me 1 minus the square root, 1 minus 3x. The square root times the square root just gives me what's underneath. And then a negative times a positive is a negative, and 2 times 2 is 4. And in the denominator, I'm going to make my denominator longer. I still have x plus 1, which is what was making the denominator be 0. And now I have this square root thing down there, which is not equal to 0. If you were to substitute into this piece right here, that's the square root part, it wouldn't be 0. So the piece that's 0 is still x plus 1, and that's the piece that I need to cancel out. So that's the reason I'm not multiplying, because I need to cancel that out so that I will not have 0 in the denominator anymore. So in the numerator now, I have the limit. I haven't found the limit yet by substitution, and I'm not going to attempt to find the limit again until I cancel out the x plus 1. So I have minus 3x minus 3 divided by, and so I just combine like terms in the numerator, x plus 1 times that square root plus 2, that conjugate thing that we had. So I still want to cancel the x plus 1, and I notice in the numerator, so that's the part that I have the x plus 1 ready to cancel. As soon as the numerator has an x plus 1, I'll cancel. And now I'm going to factor out a negative 3, and it will have the x plus 1. So the limit as x goes to negative 1 of negative 3, x plus 1, and in the denominator, x plus 1, and that conjugate thing. And now the x plus 1s cancel out. Boop, boop. And now if I substituted, the part that made the denominator 0 is gone. And so it canceled with the numerator. Hummingbird just came right up to the window, and I know what that hummingbird was saying. I normally am at the kitchen window, and now I'm out a side window, and he's like, "What are you doing over there? You're in the wrong spot." And so now I am gonna find the limit, and I'm gonna find the limit using substitution. So I'm not writing the limit sign. So in the numerator I have negative 3, and in the denominator I'm substituting in for x negative 1. So when the dust clears, in the denominator, I have 2 plus 2, because this is the square root of 4, plus 2 is 4. So the square root of 4 is 2, and then 2 plus 2 is 4, and then minus 3 in the numerator. So that is my slope, negative 3/4. And I'm going to just go back and put here slope of the tangent line. And it's the slope of the tangent line at this particular point that we had right up here. And they asked me to find the equation of the tangent line, and what I needed to know to do that was the slope of the tangent line, and I needed the point, and I was given the point. And so now I'm going to use the equation that finds the equation of a line. And it doesn't matter if it's a tangent line or any line, whatever line that you're trying to find the equation of. And that is this: y minus y1 equals m times x minus x1. And what I have going on is our point, our slope. I'm going to write slope right here, -3/4. And our point, which is -1, 2, this is x1, y1 that I'm going to plug into this formula, right? And this will be the equation of the tangent line. So this is y minus 2 equals m, which is -3/4, x minus -1, so plus 1. And then I just want to solve it to y, for y, to make it look a little bit nicer. And so because these are like terms, so it's good. If I had a bunch of pi's and square roots and all of that kind of thing, then I might not want to do that. And you might be thinking, are there any that have that? And the answer is, yeah, do a couple of the problems and you'll see some of them. And so I am, these are like terms, and so I'm for sure want to just add them together. So y equals -3/4 x, and then -3/4 plus 2 is what I'm going to do. And so with my calculator, I don't know if you can see my calculator screen, almost can see my calculator screen. I have a situation going on with lighting here too in my new studio that I'm using. And so -3/4 plus 2 is 5/4, so plus 5/4. So that's problem 8 out of your book. And they asked me to find the equation of the tangent line, and I used the definition to find the derivative because that's all that we had done in 2.1. Okay, so here's another example for 2.1. This one is problem 31 out of your textbook, and it says I have 5x divided by 1 plus x squared, and it asks me to find the derivative at 2, and then use it to find the equation of the tangent line to this curve, y equals this. That got on. I hate when that separates like that. Do you hate that too? I do. I really do. At the point 2, 2. If I was to put in here x is 2, I would find that y is 2. So what I need to know in order to find the equation of the tangent line, because that's what it's asking again, is I need to know two things. I need to know the slope of the tangent line, and I need to know a point. And this point is 2, 2. They're giving me. So I already gave that. And I want to know the slope of the tangent line at this point. And so, and actually, friends, that notation for that, because the slope of the tangent line is the derivative, I need to know the derivative at 2. That's what I need to do. Okay, so we're going to give a whirl to doing that. So I get the choice of the two different definitions for the derivative. And so whichever one I want to use is okay. And so if you're wondering, well, what were the definitions of the derivatives? They're right here, right? So I can use this one right here, or I can use this one right here. Because I used this one on the last example, I'm going to use this one. I actually prefer this one most of the time. And so that's, anyway, it's all good. And so I'm going to write that right here. So in this case, I have capital F, so it's capital F. So capital F at A equals the limit as h goes to 0 of f at a plus h minus f at a, all divided by h. I'm just going to make sure that I got it. right there. Yep, I got it. I changed the lowercase f to capital F because that's what we had in this one. And then RA is 2. Are you guys okay with that? I had to have a sip of my tea. And our F at A, right here, our A is 2. And right here, our F at 2, we need to find F prime at 2, but our F at 2 is also 2. So there's a lot of 2's running around in this problem. And so I'm going to put this in here. So I'll be finding F prime at 2, which is the slope of the tangent line at 2. And I have the limit as h approaches 0. And then I'm going to have F at 2 plus h minus, well, F at 2, all divided by h. And then I'm going to write my function right up here with a blank. People who don't do this don't get the right answer all of the time. And so if you want to get the right answer all of the time, why didn't I put a parenthesis? Because I was talking. And so everywhere you see x, you put a parenthesis. And what we're going to be filling that parenthesis in, I got to move it down a little bit, but there it is. I'm going to be filling that parenthesis in right here with 2 plus h. So everywhere I have the parenthesis, right here 2 plus h, right here 2 plus h. So right here 2 plus h, I had to write it small because I didn't write my parenthesis big enough. 2 plus h, had to write it small. This one's just too small. I'm going to have to widen it. 2 plus h quantity squared. Okay, and that's what's going to go right there in place of f of 2 plus h right here. So this is the limit. I hope I had enough room to simplify this sucker. This is a lot of algebra. So in the numerator, I have 5 times 2 plus h. And in the denominator, I have 1 plus 2 plus h. It's not funny when I'm having to do this much algebra. Minus, and I typically would have to be, you notice I'm having to write smaller because I started worrying about room. I typically put parentheses right here when I replace. The reason I didn't on the last one, and I might get away with it and not do it on this one as well, is that this is a monomial and it's just a term. It's just a number. It's 2, and that's the reason. But if I was having variables over here too, I definitely would want those parentheses. So I guess it's probably a good habit to put them always. So now I'm looking at that and I'm thinking, oh my, if I put in 0 for h, then I would get 0 in my denominator. That's why I can't do it. And this value right here would probably be 2. And then 2 minus 2 is 0. So let's make sure that it is before we go on. So if we put in 0 here, the numerator is 10. And if we put in 0 here, that is 1 plus 4. 2 squared is 4. So this is 5. So the numerator's 10 and the denominator's 5. And this is 2 minus 2. So it's 0 over 0, right? And we know from our limit doing, right, that when you have 0 over 0, which is what I have right now, I'm not substituting in, but if I did, it would be indeterminate. And so what that means is that you got to indeterminate. I don't know what I was spelling, but it wasn't indeterminate. And that means that I have to do algebra so that the h cancels in the denominator. And I'm not real thrilled about that, but I can do it. And this thing right here is a complex fraction is what it is, because the numerator is a fraction as well. And so what you have to do when you want to work with a complex fraction is multiply by the denominator. So right here, I'm going to multiply that denominator. I have no other denominators. So that's all that I'm worried about. I'm going to get a pen out here, and so that I can really highlight what I'm going to have going. Is this pen never been used, and so it has the plastic on it? I think that might be the case. It's a brand new pen. So right here, I'm going to multiply this numerator right here by, I'm going to extend it by that denominator. I know, never do math in pen. Particularly a pen that's got that plastic. They put plastic on it so the ink doesn't get out when you buy it new. Man, I need tweezers to get that. Can you believe that? That was awful. squared. Now what I do to the numerator, I got to do also in the denominator. That's a 2. I'm trying to multiply by this denominator right there is what I'm doing. And you're like, oh my goodness, are you kidding me? And so in the denominator, I'm going to do the same darn thing. Now in the denominator, I just want to leave it because remember, I want to cancel the h because h is making the denominator 0. That's what makes it, the numerator being 0 and the denominator being 0 makes it indeterminate, but it's really the denominator being 0 that's the problem. And so when I do multiply, so this is a binomial, and so I'm going to have to distribute that to both of them. And I kind of want to do that with my finger. And so when I multiply here, will you guys allow that so that I don't have to write it all? But when I multiply this fraction times that, the bottom should cancel. And that was why I did that. And so what that will end up making me have is this thing that looks like this. 5 times 2 plus h, and then the bottom cancels, right? And so done. And then minus, and then this doesn't have a bottom, so it's going to be 2 times 1 plus 2 plus h squared, and then all over the same darn thing. H times 1 plus 2 plus h quantity squared. Oh, have mercy. Okay, so there we have that. And it doesn't look like h is going to cancel in the numerator, but guess what I just got to do? I just got to multiply all that together and combine their terms and be really careful. And when I do, I'll have an h that I can factor out, and I'll be able to cancel my h. So that's what I have to do. So there's some pieces that I can kind of pull out to the side and that I have to do first. Squaring would be order of operations. You have to do inside parentheses, right? Parentheses are the first thing in the order of operations. But then inside the parentheses, I have that squaring. So I have to do that squaring. And that's exponents. So I'm over here multiplying 2 plus h times 2 plus h. So when I do, I get 4 plus 2h plus 2h plus h squared. So 4, I must be nervous, breaking my pencil lead like that, plus 4h. I am nervous. I'm nervous that this problem won't fit on this page. And so, and then I started out here really big and all flamboyant, and all that. And I'm like, all my, everything all spread out. And I'm like, why did I do that? I should have, and I can't make this video again, so I can't stop. And I don't even have more paper. And so, it's one take. That's all I got. And so, and then I'm going to add 1 to that. After I do that, y'all agree with me that that's 5 if I add 1 onto this 4 right there. And so so right here I'm going to have the limit as h approaches 0, and this is 10 plus 5h minus 2, and then in here I just got this that I just did over here on my side paper, and I'm going to add 1 to it, and that's 5, and plus 4h plus h squared. So right here, 2 plus h quantity squared, I FOILed it out over here. When I added 1 to it, because that's what I had in there, I got 5. And then now in the denominator, I have the same crazy thing, and I'm not gonna multiply the denominator together unless you wanted to. If you wanted to multiply the denominator together, you can. I'm not going to multiply the h, but if you wanted to, you could multiply this together or leave it alone, your choice. If it's the same thing that we have here and here. So if you wanted to say, well, that's going to be 5 plus 4h plus h squared, cool. In fact, I think I'll do that. Just because that double square thing and the double parenthesis thing is, it's at least taking a toll on my mind, if nothing else. And now I'm going to do one more time the limit. I think one more time, maybe twice. I don't know. We'll see. 10 plus 5h minus 10. I'm distributing the 2. Minus 8h minus h squared. 2h squared. Where did my 2 go? All divided by h times 5 plus 4h plus h squared So in the numerator, everything that has a no h on it should cancel out. And you notice the 10s do. So 10 minus 10. And then I also, so one more time, I said one more time, but then it was one more time, and then it was one more time after that. So let's see, 5h minus 8h is minus 3h, minus 2h squared, all divided by, and then h times 5 plus 4h plus h squared. And I'm going to allow myself to go this direction. I usually like to go straight down, but no, I'll keep going straight down. I'll have faith that it's going to fit. I'm going to factor out an h and cancel it. Kind of low on faith right now, feeling like I wrote too big at the beginning. And this problem got longer and longer. I laugh at myself sometimes that I won't have time to do a homework problem or something, and I'll leave a tiny little space for it, and then do the other ones, and then that one's really long, you know. But here I'm finally there. The h is canceled out, and now I can plug in h is 0. And when I do, I will know the slope of the tangent line, or f prime at 2. So that's what I'm going to know. And so whatever you want to call it, both are the same thing. So when I plug in h is 0, in the numerator I get negative 3 times minus 2 times 0. I want everyone to make sure that everyone knows that I'm plugging in 0, and I'm finding the limit by using direct substitution. And so that's how I am finding the limit. And so in the numerator I get negative 3, and in the denominator I get 5. So the slope of the tangent line, which is equal to f prime at 2, which was one of the things that they asked me for in the problem, is negative 3/5. So that was the first thing they asked me to find. Then they asked me to find the equation of the tangent line. So I'm going to put a box around this because they asked me to find it. And then they asked me to find the equation, am I writing where you can see, of the tangent line. Okay, so what you need is the slope of the tangent line, which is equal to negative 3/5, and you need your point, which is 2, 2. So this is x1, y1, and so y minus y1 equals m times x minus x1. And so this is y minus 2 equals negative 3/5 x minus 2. So this is y minus 2 equals negative 3/5 x plus 6/5. And then I'm going to add 2. A negative times a negative is a positive. 2 times 3 is 6/5. So I think I'm okay there on my arithmetic. I tell you that that's the kind of thing the first time, or I guess the only time, I say the first time, when I took calculus, so I guess I consider taking calculus. Every time I teach calculus, I'm taking calculus. I'm not sure if that's true, but the first time I took calculus as a student, the part that was hard for me was the arithmetic and the algebra. 6/5 plus 2. I didn't know how to add 6/5 plus 2 together, and we didn't have calculators that would do it at the time. And so we do have calculators that will do it now, but it took me a little bit to figure out, you have to get a common denominator if you're going to do that by hand. And I should have known that. I know I should have, but that's the kind of thing I was weak on. And so I just put it in my calculator, 6/5 plus 2. I'm getting 16/5. So this is y equals negative 3/5 x plus 16/5. Make sure that I got that right. So this is the other thing they asked me to find, was the equation of the tangent line. So that was problem 31 out of your textbook, and we did a lovely job on that. And I think there was one more example. Oh, this was here is the curve and the tangent line graphed together. And so here was the curve. So this was the curve f at x. That curve right there is y equals f at x. And then here's our tangent line that we found right here. Y equals negative 3/5 x plus 16. I actually can't believe I graphed both of them and didn't just give you the curve and ask you to graph the tangent line, because that's normally what I do. I'm going to show you, since I normally ask that, and a lot of people have come by the office to ask me. So here was our tangent line, y equals negative 3/5 x plus 16/5. And in order to graph a tangent line, you need 2 points on it, is what you need. And one of the points you were given to start with, it was 2, 2, right? So if I put in 2 in for x, I should get 2 for y. If that doesn't work, then there's a mistake going. So I might as well give it a whirl and try it. So negative 3/5, just to make sure, right? It'll give me an opportunity to see if there's a mistake. Or maybe things are going good. So 16/5 in the denominator, 5. And so when I hit equals, I do get 2. And so I just put that in right there, and with 2 in there, and sure enough, I get that lovely point. Now I'm kind of looking, here's this point right here, 2, 2. And it is where the tangent line and the curve intersect one another. And that's what we were finding, as we were trying to find a line that goes through this curve, so that when you zoom in and you get really close, that line and that curve look exactly the same. And I might have to zoom in a little closer than what I did, but you see here that this one's actually pretty good for a pretty big window around it. Okay, now I want to get another point just to show you how you could graph the tangent line if you needed to. So there's 1 point on my line. I just need to find another one. And so I can pick x is 0 if you like, or I can pick x is 3 or 4 or 5 or whatever you think would be good. And so 0 is a nice point usually on my arithmetic. So if I put in 0, and on my calculator here, I already have that on my calculator, so I'm going to delete out the 2 and put in 0. So I did, and I got 16/5, no surprise there, right, if I put in 0. And 16/5 is around 3.2. So this is 16/5 or 3.2. So I'm going to go over 0, so starting here at the center, and up 1, 2, 3, and just a tiny bit more. And then I would take my ruler and draw a line through there. So you can see that I could have done that. I wish that's what I had. I can't believe that's not what I had actually there. But you notice that I have that same question quite a few times on the lab, where I give you the curve and ask you, after you find your tangent line, to go put your tangent line on the curve so that you can see that it's passing through the point that we were interested in, and it looks tangent at that. It looks exactly just like the curve at that point. Okay, I think that is it for this section. Nope, I'm wrong. One more. So this one says, this is problem 33 in your book. If an equation of the tangent line to the curve y equals f at x at the point a equals 2 is y equals 4x minus 5, find f at 2 and f prime at 2. So those are the things that they're wanting us to find. And so this one, we kind of have to think about it just a little bit. And we might even look back at what we had right here. And so just to kind of cruise here, and it's coincidence that it's 2, because it could have been any other number. But they asked me to find f prime at 2. Remember, they asked me to find that. And you and me, we said that's the same as the slope of the tangent line. And then we did all this work, and we found this number for the slope of the tangent line. And then on our equation, of our tangent line. So there's the slope of the tangent line. There's that number, the slope of the tangent line, which was f prime at 2. And so when I look over here, it's asking me, it says that they're going to find a tangent line at a equals 2, and they want me to find f prime at 2. And so that's just the slope of that line, is all that it is. And so that is just f prime at 2 is equal to the slope of our tangent line, right? And so that's just equal to 4. So kind of a silly question, but it and when we kind of looked back, it went pretty good. Now, when they asked me to find f at 2, in ordered pair notation, they're saying 2 and then go find the y value is what they're asking us to go and find. And I want to look right here, just so that you see, we're just remembering. And this one happened to be coincidentally 2. I mean, it's just a coincidence, I know. But remember, they gave me the point here 2, and then they said, here is that y value. Well, how could we find that y value? We could put it right here into our equation, but the problem is that they didn't give me that. But there was another place we could find it that they did give me. Do you remember when we put in 2 right here into our tangent line and we found it? Well, they have the same point. And so since they have the same point, so they're the point they share in common. And so they're asking me to find the point on the curve is what they're asking me to find, but they didn't give me the curve, but they did give me the line, and it's the point they have in common. So the good news is that I can just go to the line and plug into y equals 4 times 2 minus 5. So y equals 8 minus 5, which is 3. And so the y value is 3. So f at 2 is equal to 3. So f prime at 2 is the slope of the tangent line, and that is equal to 4. So I can look at that line right there and probably remember, you probably remember y equals mx plus b, right? And the coefficient of x is the slope. And so the coefficient right there is the slope. And so that's our derivative. And then this point that they were asking on the curve is the point that the curve and the tangent line share. And they don't share but one point. They could share more than one point, but they for sure share that point. I mean, if this curve came up here, they might share, it doesn't, but if it did, they could share 2 points, but we're looking right here at the point they share. Anyway, okay, that was kind of fun. And look how much room we had for this problem, and we didn't even need all that room. Okay, I think that's the story there. Yay. Okay, stop recording. I should end give it a thumbs up and like and subscribe. That's how other YouTubers end. But really, I don't care if you like it or subscribe. I hope you like it, but you don't have to subscribe. But if you do subscribe, then I might get over 100 subscribers. Wouldn't that be cool?